Sir, how ARM processor works. So we have seen so many things about microcontroller, microprocessor, difference between microcontroller and microprocessors, then how microprocessor works, similarly how microcontroller works. Microcontroller is of different architecture, von Neumann architecture or hardware architecture, microcontroller or microprocessor it may be. Von Neumann architecture, Harvard architecture. Von Neumann architecture means both data and code memory are there as the same memory, whereas Harvard architecture means data memory is different, where data only stored, code memory is different, where code only stored. That is Harvard architecture, right? So von Neumann architecture and Harvard architecture are the two architectures associated with either microcontroller or microprocessor, doesn't matter. Anyone can lie under this architecture. Other than that, we have seen two more interesting architecture, RISC architecture and CISC architecture. How RISC architecture features are there, CISC architecture features are there. Reduced instruction set, complex instruction set architectures. In detail, those architectures you should know. The examples, the detailed descriptions, all those stuffs you know. So CISC architecture is usually for general purpose applications, what you call it as microcomputer or computers, all the related central processing units which are associated with general purpose applications are associated with architecture called as CISC, CISC architecture. Whereas RISC architecture is always associated with embedded systems. Any embedded system when you design, usually we say that what is the architecture it has. It has a von Neumann along with RISC architecture, usually we say. RISC architecture is always associated architecture. What is the beauty of RISC architecture when I say? Then you should clearly specify what is RISC design philosophy. One question might be asked, can you explain me RISC design philosophy? RISC design philosophy means set of design rules are associated with the RISC architecture. What are the set of rules associated? You already know that it is having, RISC architecture is having instruction, it is having special registers, it is having the pipelining structure, it is having load and store architecture. These are the four important property of RISC architecture. RISC architecture is associated with whom? Any of the microcontroller usually associated with RISC architecture. It might not be or it might be. Most of the things are associated with RISC architecture. But RISC architecture is having those four features as the minimum requirement. Anything else it might have also RISC architecture. Detailed explanation why that instructions as a rule for RISC architecture. Reduced instruction set. It is the beauty of RISC architecture. When I say reduced instruction set, it means that all instructions can be executed in single cycle. That is one beauty. The other thing is, since the instructions are reduced in number so that it occupies less memory, quickly it can be, the task can be easily executed. Okay, a big task can be divided into small tasks and executed parallelly is the pipelining concept of RISC architecture, and it can have so many registers. Instead of again and again tempting to use the memory, outside memory, once I call the program from the memory, everything should happen with the registers only. So such a way the instructions are designed. Instructions are associated with registers. Registers plays an important role in the RISC architectures. So that is what the third concept. The fourth concept, we said that load and store instruction architecture is associated with RISC because we say that load and store are used to fetch the data from the memory and load the data to the memory. So we should not say like this. Load means get the data from the memory to the processor. Store means get the data from the processor to the memory. So memory will be accessed only using the special instruction in RISC architecture called as load instruction and store instruction. That's what it is clearly separated as load store architecture of RISC technology, you can call it as. So in general meaning, RISC has four features minimum as its own requirements or the rules. That is called RISC design philosophy. CISC ARM design philosophy, when I say now I'm interested in ARM 7 TDMI processor. ARM 7 TDMI processor, what it is, somebody asked. ARM 7 TDMI processor is a microcontroller. It is a 32-bit RISC microcontroller. When we say it follows the RISC architecture. when I say it follows the RISC architecture, those design features what I mentioned for RISC architecture will remain same for this ARM architecture. That's it. So if somebody asks, explain a little bit about ARM7 TDMI architecture, you can say it is a 32-bit RISC architecture. It has so and so. What is that? It has instruction set, it has registers, it has pipelining concept, it has load and store architecture are the minimum requirements. Along with this extra features, if it has, then I can clearly define the name for the ARM processor as ARM design philosophy. Explain something about ARM design philosophy if somebody asks, then you should say it has a RISC architecture along with that extra features. What are the extra features we mentioned? We mentioned clearly that it may have the variable instruction for variable size instruction, you can say, and those can be executed in multiple cycles, not only single cycle, because RISC, we said that it executes the instruction in single cycle, but ARM processor can support RISC. Along with that, extra feature is it can have variable instructions which are especially associated with load and store instructions to fetch the data to the registers or use multiple number of registers. Such instructions may take multiple cycles. The variable cycle, you can say variable cycled instructions can be supported by ARM design architecture. ARM design architecture also supports what is that called as the special instruction set, which is called as thumb instruction set. Thumb instruction set is a 16-bit instruction set. It has an ARM instruction set, which is 32-bit instruction set. It also has the thumb instruction set, that is an extra feature of ARM design philosophy. What it does, if I have 16-bit thumb instruction, it means that I am supporting 16-bit memory locations. So memory can be either 8-bit memory, 16-bit memory, 32-bit memory, 64-bit memory. At a time, if I am accessing 32-bit at a time, such a memory I can call it as 32-bit memory. So that is associated with the ARM processor, because ARM processor is a 32-bit processor. But ARM processor can also simultaneously execute the instructions from 16-bit memory also. How it access or how it fetches the data using 16-bit thumb instructions. So that's what thumb instruction is, an extra feature. Another extra feature is conditional execution of the ARM processor, which RISC processor might not have. Conditional execution means before the instruction executes, the condition is satisfied. If the condition is not satisfied, instruction won't get executed. So such an initial care is taken, conditional execution. So likewise, it has extensions also. The fourth feature of ARM design philosophy along with RISC is it has extensions. It has extensions means, so what we just now referred, core extensions, it has extra features. For example, it supports 16 cross 16 multiplication, which cannot be easily achieved by any microcontroller. So ARM design philosophy has that feature. It means it supports some extra extensions or extra features supported by this processor, which is ARM processor. So that is what the ARM processor. So what is the fundamental of ARM processor? We started discussing in the last class. We said that ARM processor works like this. Basically, it has set of registers. That's the beauty of ARM processor. Everything, it means that the working principle of ARM processor starts with the registers only and ends with the registers only. So registers plays an important role. So registers are the temporary storage device, basically saying. Along with that, instructions makes use of these registers for the execution, makes use of these instructions, you can say. And now when I say how processor works, you need to bring the functional blocks connected by lines. It means all the functional blocks communicate with each other with the flow of data using the lines called as data buses. So all the functional blocks are connected by data buses. That explanation clearly I gave in the last class. So ARM processor fundamentals has registers. It has a special register called as current program status register. Current program status register has a complete big beauty, what I mentioned. It has the concept of understanding how the processor is. The processor can be in which mode. So there are different modes of processor that is decided by the value present in the program status register, one of the register. So it means that what is the value present in program status register, which set of values decides where the processor is, whether the processor is in this mode or in that mode. I told in the last class there are 6 modes of the processor. What are the 6 modes? I said the first one is the system mode or user mode. The second one I said interrupt request mode, fast interrupt request mode, supervisor mode, undefined mode. So like this, total 6 modes of operation are there. Mode is how this mode, what is the meaning? It means that if the processor moves into this mode means mode of operation. It means who decides the mode of operation? The values present in the current program status register. Which values? That we will see now. So with that values, if the processor is in that mode, then the meaning of that, the meaning is these registers are usable by the processor. When the data comes in, the data can make use of only those registers and only those functional blocks are associated. So almost all the functional blocks are accessible. Only few registers are limited for the different modes, and few access rights are also reserved for different modes of operation. So the processor can operate in 6 modes. That you should keep it in mind. So then we say bank registers. It means that I have set of registers, whether all the registers I'm using in the processor mode. So processor mode means a mode of operation of the processor. If I'm in one particular mode, I can have access to only these many registers. That's the condition we are putting by making use of current program status register. So current program status register is the important and heart of your ARM processor registers. Out of all registers, current program status register is the most important register. So state and instruction set. It means if I am in ARM state, then I should say that which bit should be set to say that I am in ARM state. What is the meaning of ARM state? ARM state means the processor is in a particular mode and it is making use of ARM instruction set. It is making use of 32-bit ARM instruction set. If it is making use of 16-bit thumb instruction set, then the state must be thumb state, ARM state or thumb state. How to set that? Set the value in the current program status register, then the processor is in ARM state. That's the indirect meaning. Similarly, as I mentioned, instruction set. So it has interrupt masks. There are 2 interrupt masks. Because we said already 2 interrupts. There are 2 interrupts. It means when the processor is running with the data, it can be interrupted by external device using interrupt request, using a signal called as interrupt, or it can be fast interrupt. There are interrupts. How they can be controlled in unit completely will study about exceptions, interrupts with the examples. Let us don't worry. 2 interrupts are there. They are also kind of instructions, you can say. What happens? They stop the processor execution and takes away the processor to some other routine or some other loop, you can say. Okay, so that is done because interrupt has been sent by the external device. Now I don't want this interrupt to disturb my processor. Then I have the concept called as interrupt masks. There are 2 interrupt masks, I and F. Okay, I is for interrupt mask, F is for fast interrupt mask. So these 2 bits helps us to mask the interrupts. Avoid the request from the external device can be done by interrupt mask. There are important concept called as conditional flags. These are set after the execution of certain instructions. So what are the conditional flags? I have 4 different conditional flags. One is called as what is that? Sign flag. Second is called as zero flag. Third is called as carry flag. Fourth is called as overflow flag. These 4 will be set based on the operation of instruction. For example, if I take an instruction add R1 comma R2 comma R3. So R1 and R2 values are taken, added up, that is stored in R3. That is what the instruction says. While adding, I will cross check whether these conditions are met. What are those conditions? Whether carry flag is set, whether zero flag is set, whether over flag is set, or what I call it as the other one more flag, sign flag is set. So how those things will be set, that is based on some examples. Those examples clearly will study in instruction set. So though we'll now only understand that those bits are set only when that result happens. If carry comes, then the carry flag is set. If the result is zero, then zero flag is set. If the result is non-zero, zero flag is not set. If the result is having overflow bit, then the overflow flag is set. So this is how the set operation happens with respect to the current program status register, depending on which mode the processor is there. That's what the very important aspect is, the processor modes, which is decided by current program status register. Similarly, the simple explanation. Yes.
Sir, what does flag refer, sir?
Flags, that's what, those flags are the bits in the register. That's what I'm saying. Those bits are set or not set, tells us what is the actual operation has happened. It means current program status register has initially these flags set or non-set to makes the processor going for operations easily. So it means in a particular processor mode I am there. When I execute a particular instruction, immediately those flags will be set if that condition is satisfied. That's what conditional execution here by ARM processor we say no, these are filled in the current program status register. The flag is set or not set. The meaning is whether the carry has occurred or not, the processor will come to know immediately, and it takes the next next task based on that. You will come to know when I discuss some instructions, data processing instructions, how it happens. These flag details will completely come into picture. So that I'll discuss more. So pipelining is nothing but parallel execution, how we are going to do it, because there might be three stage execution, 5-stage execution, or 6-stage execution, depending on ARM7, ARM9, ARM11. They execute the instructions parallelly. That is pipelining concept. Some core extensions, what are the additional features, those will come across. So then depending on the type of instructions, we'll do architecture revisions and we will classify them as ARM7, ARM11, ARM Cortex. So this is the flow we have seen. Again, I just don't want to explain much about this. ARM core, how the ARM processor works. When the data is fetched from the memory, it will be sent immediately to the instruction decoder. If it is an instruction, it converts the instruction into machine code. If data is already in machine code, directly that comes to sign extend. Sign extend is the one which takes the signed bit, either 8-bit or 16-bit, whatever the data comes, it converts into equivalent 32-bit. It is a signed data or unsigned data, that conversion will be done. One or two examples while doing the instruction will come to know the operation of sign extend, how it works. When the data comes, that is 32-bit, that will be initially stored in the registers. R0 to R15 are the registers. Any registers it can be stored. Register I'm saying because what the instruction having, if the instruction is having the register name add R1 comma R2, it means that the first data comes and goes and sits in R1, R2 likewise. So as the name itself indicates, based on the names, the data goes and sits in the registers. So the register file is the collection of all those registers, total R0 to R15. So how many registers are there? Which are all types of registers? How they named as, that you should know. Now Rn and Rm are named as source register, Rd is the destination register. Simply the data taken from the register file because as per the instruction, the data is taken. Okay, Rn and Rm are the two registers. From that, the data is taken, given to the ALU. ALU does the operation which is called as add R1 comma R2. If I take example as R1 and R2 are the source registers, that data is taken, adding operation is done, and the result is stored in RD. RD here is R3 I called. It will be stored in R3. It's a simple example. Like this, any sort of example if you take, they are making use of registers and realizing the operation. In between, there is a barrel shifter which clearly helps us to do many important tasks. What type of task we'll come to know while dealing with the instructions. Especially barrel shifter, as the name itself indicates, it is having the concept of mux inside, and it does multiple shift operations. It does multiple shift operation in a single cycle. How it does? When we are discussing with instructions thoroughly, we'll come to know the operation of barrel shifter very easily. Barrel shifter along with ALU does very complex expression solutions. That data goes and stored in destination register RD. Similarly, MAC is also there, an extra block. As accumulate is the word, it's also a temporary storage, you can say. Multiply and the data which comes from the two buses called as A and B. So that data is taken, multiplied, and the result is stored in accumulator, then passed to the destination register RD, assigned RD. Along with this, the extra operation which happens here is the load store architecture always. Not only all the instructions, data processing instructions or any other instructions happens with these registers, ALU, MAC, block only. Extra operation is nothing but load store operation. Load store operation means loading the data from the memory to the register, that is called fetch operation. So please remember, first operation we started is loading. Next store. Load and store architecture the processor is having, I said. So load and store both happens with the help of this address register. Please remember, what is this address register? When loading has happened, ALU helps to store the address of the memory in the address register where the result has to be passed. So address register carries the address of the memory. So when first operation is completed, the incrementer increments this register value. When the first operation is completed, incrementer increments this operation. This process continues. So step by step, after completion of instruction by instruction, the result, if I want to store back in the memory, I'll use the concept called as write. You can see here write operation. So write operation is going towards the memory, that arrow key you can observe. So address bus carries the address, write operation writes on to the memory. So that point you should remember. Every time checking data is the counter. What does that program counter do? It increments the memory address and fetches the instruction one by one. Once the first instruction execution is done, storage is done, then the next instruction should be pointed by this PC only. So PC will have new address. That's the idea. This is the simple working principle what we discussed. And we started discussing the details of all the things which are associated with the processor. We started with the registers. Now, how many registers are there? Total 16 registers are there. So to say, there are total 18 registers. There are, now be very much clear with this. How many registers are there in ARM core processor? There are 18 registers, out of which 16 registers are called as data registers or data processing registers, you can call it as. They usually data registers, okay, which stores the data. Okay, now again I can call in a simple meaning as these are all data registers, and now CPSR and SPSR are the special registers. Okay, those are the functional registers of the processor, you can call. In this, again we are saying R0 to R12. R0 to R12 are called as general purpose registers. R0 to R12 are called as general purpose registers. R13 to R15 are called as special function registers. R13 is used as a stack pointer. It means that R13 is a 32-bit register. It handles the address of the top of the stack. Stack is a separate memory location whose starting address will be stored in R13 so that it helps the process to store the value. So top of the stack. R14 is the link register, LR. R14 is a special register called as link register. It stores the return address when the processor branches to some other memory location. When it will branch to some other memory location? It will branch to some other memory location when the interrupt happens, when the interrupt signal comes. Interrupt signal comes, immediately the processor jumps to that particular location. From there it starts execution. So to come back, I need to have return address. That return address will be stored in R14. So R14 carries the return address so that the processor looks into return address and comes back to it. R14 carries return address. How the execution of that particular instruction, in one of the instruction we will see. R15 is the PC program counter, which points to the address location of the next instruction to be executed. It will always be getting incremented by incrementer, you know that. So that PC automatically points to the next address location where the instruction has to be fetched. These are the registers which is called a general purpose register and special purpose register. But two most important registers are CPSR and SPSR. CPSR is current program status register where the processor looks into it. No other registers can be looked into it that much thoroughly how the processor looks into CPSR. So CPSR is the most important register. Its values are set. Values means what? CPSR is a 32-bit register. It has 4 different sections of each 8-bit. I told them. So processor sets those values by being in a particular mode. If the processor is in this mode, these many bits can be alterable. That's what we will see. So CPSR, how CPSR looks like? A question might be asked. Describe the CPSR register and its functionality in detail. So it has 4 modes: flag mode, state mode, extension mode, and what is that called as control mode. So each of 8 bits, because totally it is 32-bit. You can observe now 0 to 7 bits are there. 0 to 4 bits are reserved for mode operation. 5, 6, 7 are 5 is for state operation of the processor. State, please remember, mode operation of the processor is 0 to 4 bits. So total 5 bits. 5 bits tells us in which mode the processor is there. If I set the 5th bit, in which state the processor is there, whether it is an ARM state or thumb state. ARM state, when I say, it means it is using ARM instruction set. When I say 5th bit as thumb state, it means that the ARM processor is in thumb state. It is using 16-bit instruction. Please remember, current program status register is a register of a microcontroller, or you can call it as ARM controller, which takes care of control and internal operations of the ARM processor. Control operations and internal operations of the ARM processor. All control operations, all internal operations are handled by current program status register, and those values are set by the processor being in a particular mode. Please understand, being in a particular mode. So that's how the values are set. So these values are set by the program itself. I can write a program to set the values of a CPSR. That is also easily possible, being in a particular mode. So now just quickly understand, these are 4 modes: flag mode, status mode, extension mode, and control mode. Status and extension are mass store here, whose operations can be dealt later when we discuss some idea about ARM extension or core extensions part. So here they are hidden. Now most important is control part. Control is first 0 to 4 represent processor mode. So what are the different modes available? I said total 6 modes. We'll come to that. Its values may be 5 bits, right? 0 to 4. Fifth bit, come to the fifth bit. If I say fifth bit is 1, then it means that I am making use of processor as a thumb state. Processor is in thumb state. If fifth bit is 0, then the processor is in ARM state. Similarly, if you see the seventh and eighth bit of this particular control field, I can call them as fields. Each bit is a field. You can say it as a field. So sixth and seventh, if I set it as I and F, it means that it is an interrupt mask or fast interrupt mask. If its values are 1, 1, it means that both interrupt masks are enabled. If its values are 0, 0, both interrupt masks are disabled. Similarly, if the fifth bit is 1, I am in thumb state. If fifth bit is in 0, I am in ARM state. So similarly, I can put the values for processor mode, say in which mode I am. Likewise, the control bits are set in the CPSR register. Similarly, I can look into the flag registers. There are 4 flags, N, Z, C, V. N stands for signed flag. Okay, Z stands for zero flag, C stands for carry flag, and V stands for overflow flag. These flags means the results when I do certain operations based on the result of the operation, these values are set or unset. Set means making that particular bit in that location as high. Reset means making that bit as 0. If n is 1, it means that sign flag is set. Sign flag means what? Either signed number or unsigned number. N is 1, it means that it is number unsumber. How to present a signed number and unsigned number, you may ask a question. So that's a simple idea. If I ask you, can you write minus 124? Yes, minus 124, if I told you to write, you will immediately write stating that uh, if all ones in 8 bits, if all ones in 8 bits, it is if all ones in 7 bits, let's say 7 bits, it is 127. 128 means 1 followed by 7 zeros. So the first bit I will declare it as a signed bit. So if I call it as a signed bit, it is a negative. If it is a negative, when I say 1 represents negative, because it's a signed bit. So either it may be 0 or 1. Sometimes when I say the number as unsigned number, 0 and 1 doesn't matter. The positive or negative, it doesn't matter. So that's what, while indicating a signed number, I should be very careful how to represent that. We'll see with one or two examples how to represent a signed number or an unsigned number when the value of n will be 1 or 0. That part, how the processor sets this value as 1 or 0. Similarly, how the processor sets the values z as 0 or 1. So it sets either z as 0 or 1 depending on the result which is obtained. If I subtract, if the result is 0, and it means if two numbers are equal, then 0 flag is set. If two numbers are not equal, 0 flag is not set. Similarly, if carry comes, carry flag is set. No carry, carry flag is not set. If some result overflow happened, it means that I have 32-bit register. If the result is 64-bit, then definitely there is a overflow. So when overflow happens, this flag is set. If overflow happens, what care should be taken? If non-overflow, then nothing to worry. So this indication condition before proceeding with is valid. This is the operation you should explain current status register. Now, when I say the mode operation, so I said 0 to 4. These are the bits which decides whether the processor is in this mode or that mode. What are the different modes we have? Different modes we have like this. I'll come to this value. Different modes. The processor modes can be abort mode, fast interrupt request mode, supervisor mode, system mode, okay, undefined mode, and user mode. You observe the values. Mode value Value here is, see, mode 4 down to 0. So 4 bits. What are the values? 10111. If I put the value in the CPSI registers from 0 to 4, these values, it means that the processor is in abort mode. So all these are usually called as privileged mode. So usually the processor is in user mode. That is called non-privileged mode. There are two types, privileged mode and non-privileged mode. You can observe SSS for it and no for user. So user mode is a non-privileged mode. Meaning is very simple. Privileged means you are having rights, access right to read and write the values in the CPSI register with any of the blocks concerned. It means I can read, I can write onto the conditional flags, I can read and write onto the status extensions and control fields of the CPSR register. I said four fields are there, four divisions. Okay, so I can read and write the data onto the CPSR without any worries. That is called privilege mode. Whereas in user mode means it is also almost privilege type only, except the conditional flag field will not be disturbed by the mode which is called as user mode. Usually when we are executing the program, usually we are in user mode. It means the processor itself will set the values of conditional flags so that the execution process continues without any worries. That is what the conditional flags helps. How it helps, an example will come now. The process those values, how it helps continuously and simultaneously uh, with a greater speed of the clock. So that is what the six different modes. Please remember, abort mode, fast interrupt request mode, supervisor mode, system mode, and undefined mode are the privileged modes. And the other mode is the user mode. Now come back to this. What is this? If you see now, the first set of registers which are in white color are not to R15, R0 to R12 are the general purpose register, R13 to R15 are special purpose registers, and the CPSR and SPSR, which are the control registers. Now all these registers, total 18 registers, falls under user or system mode. Here these registers fall under a particular mode. It means the processor is in user mode or in a system mode. They are having access rights to all these registers except the conditional fields of the CPSR. That's what the user mode is, a non-privileged mode. Now, when I immediately set the values differently, mode values 0 to 4 in CPSR register, here you can observe mode is there here, 0 to 4 value bits. If I set it to some other value, I can fall under fast interrupt mode or interrupt request mode or supervisor mode or undefined mode of operation or abort mode of operation. If I fall under fast interrupt request mode, I'll be able to access R8, R9, R10, R11, R12, R13 and R14 registers. No other registers. You can see the block. These registers are only accessible by the processor. Remaining blocks are disabled. Remaining registers are disabled. That's how the processor is designed. ARM processor is designed. Different ARM families, these register group may change, but ARM7 TDMI has this bank of registers. This is called as bank of registers when I'm in a particular mode. So I can be in fast interrupt mode. Fast interrupt mode, I will go only when there is an interrupt request comes. Okay, which is of fast type, fast interrupt request or interrupt request. If I'm just in interrupt request, only 3 registers are allowed me to use. That's what the name they have given, FIQ, fast interrupt request, IRQ, interrupt request, SVC, supervisor mode, undefined mode, abort mode. So you can observe supervisor, undefined, abort and interrupt request. All these modes are making use of only 3 registers, R13, R14 and SPSR registers. That's it. We'll come to know in detail when we do certain programming. So how mode change will happen? So changing the mode on exception. So when I there in the user mode, suddenly I'll enter into the interrupt request mode. R13 will switch over its operation as R13 IRQ. R14 LR will switch its operation as R14 IRQ, and CPSR is changing its operation to SPSR IRQ. Only these three registers are enabled or kept enabled, remaining all are disabled. Remaining all are disabled is the meaning of changing the mode of operation. That's the simple way of explanation. That's what you see the explanation simply. What he says, you just make a note of here. What is that? Abbreviations for all different modes. ABT for abort, fast interrupt request means FIQ, interrupt request means IRQ, supervisor abbreviation is SVC. These words you should remember. System mode means SYS, undefined UND, user is you heard user. So which are all privilege mode. And these values, if you remember, it's well and good. You try to remember 32. User is 32 because 0. You can say sorry 1 2 4 8 1 2 4 8 16. Sorry, what is that? Yeah, 1 2 4. No, I should say yes. Okay. Uh, it is 16. Yeah, correct. 0, oh, sorry, 1 2 4 8 16. User is 16. You observe, user is 16, correct. I mean to say the weight I'm giving 0, sorry, 1 2 4 8 16. So user is 16. 17 is for fast interrupt request. Value I'm telling, decimal value I'm telling. Similarly, interrupt request. Interrupt request you observe. What is that? 16 plus 2. 16 plus 2, 18. Similarly, supervisor. I'll just when I'll be supervisor, if the mode value is 10011, it means that 16 16 plus 2 plus 1, 19. So 19. So likewise, you can have the decimal equivalent of this, and remember that if the value of 0 to 4 bits of that particular CPSR register is this, I'll be in this mode. Just see another important feature to note that CPSR is not copied into SPSR when mode change is forced due to the program. So it means that anything what we are doing is with the help of program only we are doing. Okay, writing directly to the saving of the CPSR only occurs when the exception or interrupt is raised. This process of change in the mode will happen only when there is an exception occurs. In it's kind of an exception saying that something is abort mode, or I'll say some instruction which is not there in our instruction set, then I'll go into undefined mode. That is what he see. The figure what I've seen earlier shows the of the CPSR, as you said, 0 to 4. When the power is applied, see how it happens when the power is applied to the core, when the processor is turned on, it starts immediately in which mode? In supervisor mode, which is privileged mode. So first, usually it enters into privileged mode. Starting in the privileged mode is useful since initialization code can use full access to the CPSR. So we know that how the software runs. Software is the one which runs the initialization code first, then it enters into operating system code, then some other codes. It means some other software. So initialization code is the first software or the program that will run if I'm there in a privileged mode called as supervisor mode. When the processor is immediately turned on, it enters into supervisor mode. It means that the supervisor mode value is 10011. That is the value set in the CPSR initially. That's it. Full it is in privileged mode because it is having full access to CPSR to set up the stacks for any other mode, something like that. So we have all the modes of binary operation table listed. That is what has been seen. The next important way, fifth bit. the fifth bit, as I said, if the fifth bit is 0, then I am in ARM state. If fifth bit is 1, then I am in thumb state. What is the meaning? If I am in ARM state, I'll make use of the column. See the column. If I am in thumb state, I'll make use of another column. So in the instruction size, I am making use, since I am in ARM state, if the fifth bit in CPSR is 0, I'll make use of 32-bit ARM instruction. If fifth bit is 1, I'm making use of thumb instruction. It means 16-bit. Instruction size is 16-bit. Core instructions are 58 in ARM processor. How many instructions are there if somebody asks? ARM instruction set, total 58 core instructions, whereas in thumb instruction set, 30 instructions are there. That's what add, multiply, left shift, right shift. If you list all the examples, total 58 are there in ARM instruction set, 30 in thumb instruction set. Conditional execution, yes, ARM is mostly conditional, and thumb instruction, only branch instructions are conditional instructions. Please understand. ARM instructions are, branch instructions are usually conditional instructions or conditional execution they follow. For example, JC, jump if carry, JZ, jump if not 0, jump if 0. So likewise, data processing instructions are there. They are having access to barrel shifter and ALU in ARM. If I'm using ARM instruction set, then only I have the concept of accessing to barrel shifter and ALU. Here, separate barrel shifter and ALU instructions are there for thumb. Okay, so program status register, read write is in privileged mode, no direct access. When I'm in thumb state, I don't have direct access. That's the other feature. Please remember, I can be in any mode. If the state is thumb state or ARM state, it entirely changes the processor execution. Please remember that single bit, fifth bit, if I make it 0, then only I'm making use of all the processor modes along with ARM instruction set. If I am in thumb state, I'm in thumb state, then I'm making use of instructions and I have certain privileged modes. That constraint will come. So fifth bit is very important bit. That's what he clearly says here. Along with that, there is one more bit. What is that bit? That bit is called as Jajale instruction set features. If I want to use, I don't want ARM instruction set. I don't want thumb instruction set. It means I want the ARM processor to support Java based instructions. Java is a language, Java based instructions, an application where Java language is preferred. Some of the embedded systems, yeah, my screen is visible.
No, sir.
What happened now? Just now, it's went on. Yeah, now it's visible. Oh,
No, sir.
why it's going off? Just a minute. What happened? I'm unable to share it now. Something is visible on my screen. My screen is visible.
No, sir.
Nothing, right? 1 second. What happened? It's not at all sharing. Okay, now it's not visible, right?
No, sir.
Yeah. Okay. So what I thought of is now I thought of to stop and show the Proteus 8. Subramania, did you install Proteus 8 in your PC?
Sir, I installed, but that crack is not, license is not activating, sir.
No, it's very easily happens. No, I did in two
I know.
PCs. My laptop as well as my standalone PC at home. Both
I
I
tried, sir.
installed.
I think I might have downloaded wrong file folder.
Okay. So, yeah, because it's very important. We should go simultaneously with the lab in understanding all these things quickly. Okay.
Yes, sir.
So, what we will do is, I will show you in the morning class, 9 o'clock. We have, right? Uh,
Yes, sir.
Along with a few more steps, what I left with what is that? Mm, a simple explanation of conditional flags and one or two examples. I'll immediately jump to uh, showing the Proteus 8 along with your microvision, keel vision. Both together you should work because all the programs you should work by the time your lockdown completes, you should be thorough with the lab. When directly you come to the come to the college, you will be able to do only the left out hardware experiments. That's it. Those hardware experiment we are realizing in software only, but still to feel them in hand we will do it in lab, the hardware experiment. When you come back within 2 3 days you can be able to do once you complete this with the software. Okay, so we'll do that in tomorrow's class. I'll clearly show you with examples how you are going to interface the hardware realization with the programs. I should visualize that LEDs are glowing, LEDs are turning on and turning off. I should visualize that 7 segment displays displaying 0 1 2 3 up to 9, right? And I should visualize that I'm making use of port 0 pins, I'm making use of port 2 pins, I'm making use of pin cell registers, right? So those examples we'll see. We'll stop here. And the next class, I'll just quickly
Sir,
brush. Yeah, tell me.
sir, in that YouTube, we are unable to access the
No,
recording.
I just made. I given the privilege. No, now it is available. I think.
But
Still,
it is showing private videos, sir.
still.
Yes, sir.
Starting some 3 to 4 videos and showing like that.
Okay. No, I just made them again like unlisted clearly. Oh, let me check again. I'll put that in WhatsApp group, that statement. Okay. So we'll stop here, and a few things like regarding conditional flags, we'll just quickly discuss something, and we'll move on to the core extensions. Once we finish this, all these things what we discussed will be visualized when we do instructions one by one. Automatically you'll come to know oh, we are there in program mode, we are there making use of interrupts, we are making use of sign extension, we are making use of conditional flags. So how the values will be set by the instruction itself, things will be very much clear. So we'll deal everything with respect to instructions, that will be very clear, but now only for understanding purpose, this much is enough. Okay, and after this we'll discuss few things on core extensions and families. That part completes the first unit. Along with bit part of fourth unit, labs we should do simultaneously. So I want you to practice thoroughly with microvision along with Proteus, so that you are completely fulfilled. When you come to lab after lockdown, hardly you need 4-5 days to complete the hardware experiments, so that it becomes easier for you. I'll try to ensure that you are practicing with me with both what is that, Keel microvision along with the hardware realization using Proteus, because microvision now we need to connect it to the Proteus to see the actual view of the thing what we wanted. That Proteus design sheet will help you in that. So what is the way to download? Simple way, I clearly told you. Type in your Google Proteus 8 with full crack version, something like that. If you type and search, try to look into the link which is written there clearly, Proteus 8 with full crack version. Click that link, it will take you to some drive, right? And it will say hardly it is 161 MB, you download. When you click download, you will be able to download 161 MB zip file, which is a Proteus 8. So you just unzip it, okay? And when you see inside the folder has 4 different files. One is bin file, one is some crack file, one is license file, something like that, and one file is called setup.exe. Double click on setup, it will be start installing in your Windows PC. So when it starts installing, it goes and it asks at a position that need the license key, full license key. So there you should browse, go to browse and see in where you have copied that folder. It means where you have extracted that folder, unzipped folder. Go to that folder, there only select the license.txt file, that license file. Just select, it will select all the fields, all the keys, then say done, then close it. Automatically it continues the installation. And in between, one more point it may ask, what is that called as, do you want to import the previous library files or merge? Just click merge and then proceed. So it will ask whether you want to install typical or custom. You just click on typical. Once the installation is complete, restart your PC. That icon is available on your desktop. Double click on it. It will open the chute. Then how to utilize that chute, how to make use for writing, executing your program, that I'll tell. First installation you try to complete first. That we will see in the morning class, tomorrow's morning class. We'll stop here. No problem, right? Pramod, did you install?
Sir, today I will install, sir.
Yeah, please try. And tomorrow you will get clear picture how exactly the realization can be done. Komal GD,
Yes, sir.
you are having laptop, right? You are installed and working, right?
I'll install it, sir. I was not knowing how to install. I asked today, and I'll install it and start working, sir.
Okay, how about microvision you installed? Keel microvision you installed, right?
Yes, sir.
I told 6 programs should be completed. You remember that?
Yes, sir. I'm doing. I'm on.
LED blinking and 7 segment blinking port with respect to port 0 and port 1. Okay.
Okay, sir.
So some 6 programs I mentioned. You should have the practice with that. Okay.
Okay, sir.
In tomorrow's
Okay,
class
sir.
also again I'll show, but you be ready with both the softwares, Keel
Okay, sir.
microvision and Proteus 8. Okay.
Okay, sir.
Okay, okay, we'll stop here. We'll see you in the next class.